In the previous video, we looked at the steps for determining if there is a relationship among two categorical variables. We illustrate relationship with stacked or grouped bar plots, and then we calculate the associated proportions or percentages and display them in a contingency table. Let's turn our attention now to accomplishing these tasks using R. Even though we always begin our analysis with a picture, that is, a graphical display, I need to show you how to create a contingency table. The reason for this is that we need a contingency table to construct a stacked or grouped bar plot. This will not change the order of our analysis or the presentation of that analysis. We will still begin that analysis with a graphical display. Yet first we need to construct a contingency table, use that to create our bar plots, then set the contingency table aside and focus on the graph as the first step of analysis, bringing the contingency table back to display the proportions or percentages that correspond to the bars in our graph. I am going to show you how I created the graphs and statistics that I used in the last video to analyze the relationship of cabin class and survival on the Titanic. First, I need to load the Titanic data. Let's obtain the graph and statistics individually for each of the two categorical variables. I believe it is good practice to look at variables individually before you begin to look at relationships. We start by obtaining the frequencies for passenger class, which is the variable P class. We calculate frequencies with the table function and store the results in a variable that I have named pClass.freq. We then use that variable as a parameter for the function that calculates a table of proportions from a table of frequencies, and we store that result in pClass.prop. Let's bind these together in columns and look at them. The table of proportions is fed to the bar plot function to create the bar plot for passenger class. We go through the same steps to create the proportions and bar plot for the survival variable. The only difference is that survival was coded as 0 and 1, so we must tell R that this should be treated as a factor, that is, a categorical variable instead of a quantitative variable. Having reviewed how to create graphs and statistics for individual categorical variables, let's now turn our attention to creating a contingency table. Just as we do with a single categorical variable, we begin by creating a table of frequencies, and then we will use that table as a parameter for the prop.table function to generate proportions. The only difference in generating a table of frequencies is that we use two parameters, the two categorical variables, instead of a single categorical variable as one parameter. Let's look at this table of frequencies. Now I want to show you what happens if we create our proportions from these frequencies. This is not a contingency table. Can you see why? All 6 of these proportions add up to 1 or 100%. R has calculated proportions for us, as we asked, but it has done so by dividing each frequency by the total number of passengers. For a contingency table, we want the proportions to be contingent on cabin class. The prop.table function in R is quite powerful and can create proportions 3 different ways, depending on what you need. You have just seen the first way. This is a calculation of proportions for each variable combination based upon the total sample size. The second way is to calculate proportions contingent on each row in our table. We call these row proportions. To create these, we send the prop.table function two parameters, the frequency table and a number that indicates whether we want row proportions or column proportions. The number 1 indicates row proportions and the number 2 indicates column proportions. Here's the result if I use the number 1. These are the row proportions. For example, this tells us that of all the passengers who perished on the Titanic, 0.15 or 15% of them were in first class. The problem is that there were different numbers of passengers in each of the cabin classes, so that the proportion of those who perished that were in each cabin class would not be the same even if there is no relationship of cabin class to survival rate. The different proportions that I see here for the different cabin classes does not answer my research question because of the differing numbers of passengers in each of these classes. To look for a relationship, I need to look at the response variable contingent on or conditioned on each level of the explanatory variable. The explanatory variable is cabin class, and those are in columns, so I need column proportions. I obtain those by using the parameter 2 as the second parameter for the prop.table function. Now I have what I need. I can see the proportion who perished, or alternatively, the proportion of survivors, for each cabin class. As with bar graph construction for a single categorical variable, we are going to need to feed the table of proportions to the bar plot function, so I need to store this table in a variable. I'm going to do that now. In the next video, I will show you how to use this variable of proportions to create stacked and grouped bar plots. I'll see you there.